October 3rd, 2025, NASA's Perseverance rover on Mars snapped images of the enigmatic 3 Atlas. The shots weren't crystal clear, but they were enough to spark intrigue, and astrophotographer Simeon Schmaus meticulously stacked 20 of these rover images, revealing a faint glow precisely where the interstellar visitor was expected. The discovery has ignited discussions, analyses, and debates about what this fleeting smudge of light truly signifies. But here's where things take an odd turn. On that very same day, NASA furloughed 15,000 employees. Coincidentally, the Mars Reconnaissance Orbiter's high-resolution camera, capable of capturing details 30 times sharper than Perseverance's images, was perfectly positioned for a once-in-a-lifetime shot. The European Space Agency's Mars Express and ExoMars orbiters were also observing. So where are those images? The plot thickens. Back in August, remote viewers claimed to detect technology aboard this object, a device the size of a thumb drive deliberately embedded in an ancient comet emitting faint impulses. Their claims surfaced months before telescopes began picking up inexplicable chemical signatures. This video dives into the mystery in 2 parts. The first explores 3 Atlas and the latest findings, while the second covers this week's broader space news. Check the description for timestamps if you want to skip ahead. If this captivates you, smash that like button and subscribe to stay in the loop. Drop a comment below. Tell me where you're watching from, what time it is there, and your take on this object. Is it a natural comet or something more extraordinary? Want to help our community grow? Share this on X, Facebook, Reddit, or your favorite messaging app. Thanks for always having our back. Chapter 1. The Cylinder in the Martian Sky. 48 hours ago, a single post on X shook the world. A user named UFO Mania shared an image with a caption that sent shockwaves through the astronomy community. The newest and closest of 3 Atlas as it passes is not a comet. It's perfectly cylindrical. Accompanying the words was a striking image of an elongated object captured during the recent Mars flyby. Within hours, the post exploded, shared thousands of times, igniting fervent debate. This wasn't just another blurry backyard telescope snapshot destined for conspiracy forums. This was different. What set this apart? The coordinates aligned perfectly. The timing was impeccable. Most chillingly, the silence from official sources was deafening. On October 3rd, when 3I Atlas made its closest approach to Mars at 29 million kilometers, we should have been flooded with high-resolution images. NASA's Mars Reconnaissance Orbiter, equipped with its cutting-edge HiRISE camera, was ideally positioned. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had their instruments locked on the precise location. Multiple spacecraft, multiple angles, the best resolution ever achieved for an interstellar object. And yet nothing. No images, no data, just silence. But into that silence stepped voices that demanded attention. An account called 3I Atlas Anomaly began posting a meticulous technical breakdown far removed from typical conspiracy fare. 10 precise points, each grounded in verifiable observations: a carbon dioxide-rich coma detected by JWST water, and hydroxyl emissions picked up by swift and polarimetric anomalies, showing a negative 2.77% polarization at a 7-degree phase angle, an unprecedented combination for any asteroid or comet. These weren't wild claims. They cited real instruments, real measurements, real science. Then came a post that stopped even the skeptics in their tracks. A user named Moneypenny, identifying as a plasma phenomena expert and former BBC journalist, dropped a bombshell. She claimed a prominent cosmologist, Stephen Burns, believed the object was intelligent, enveloped in dusty plasma, and exhibiting signs of consciousness, already communicating with Earth and other planets. Yes, it sounds like fringe territory, but this wasn't some obscure corner of the internet. Moneypenny's credentials were front and center, her investigative journalism background lending weight to her words. And then she added a detail that sent chills through anyone paying attention. We can no longer observe it. It's too close to the sun. It won't be visible again until December. 3 months. 3 months of waiting with the object hidden behind the sun, invisible to every telescope on Earth. If its trajectory shifts during this blackout, we won't know until it re-emerges. The stakes feel higher with every passing moment. Then there was Jon Stewart, not the comedian, but a UFO investigator and journalist whose post read like a warning from a bygone era. My source has gone dark. NASA is shutting down, and even Congress is in recess. If 3LIS activates, ancient texts warn, the sky will burn with knowing light, and the world will forget its reflection. Prophecy, he called it. Agencies called it protocol. He called it imminent. Hashtags like Make Vatican Files and Chase Harbinger trended alongside rigorous astronomical discussions blurring the line between myth and science. How do you sift signal from noise when the noise might be the signal? Here's the uncomfortable truth. In the last 48 hours as these posts went viral, not a single official image from the Mars flyby has surfaced, not from NASA, ESA, China's Tianwen-1, or the UAE's Hope orbiter, all of which we're watching. The only visual evidence comes from an astrophotographer, Simeon Schmaus, who stacked 20 images from Perseverance's MESCAM-Z and found what he called a faint smudge of light in Corona Borealis near the comet's expected position. A faint smudge. That's all we have from humanity's closest look at an interstellar visitor captured by spacecraft that can resolve features smaller than a car on Mars. Unless, of course, they saw something else and chose to keep it from us. The 3i Atlas Anomaly account kept posting each update more precise, unexpected brightening, faster than models predicted, hinting at volatile or efficient outgassing mechanisms. ESA, they claim, was redirecting Mars orbiters to monitor the object during its solar conjunction when ground observations are cut off. Every detail checked out verifiable against published data. Yet the conclusion was inescapable: this was not behaving like a comet. And then came the shape. Multiple amateur astronomers working independently reported the same finding. After enhancing contrast and removing background stars, the object wasn't the fuzzy, irregular blob typical of a comet's coma. It was elongated, smooth, almost geometric, perfectly cylindrical, just as UFO mania claimed. Skeptics might argue elongation could be an artifact of motion or image processing, and they'd be right, it could be. But it could also be real. We know this because Oumuamua, the first interstellar visitor, was also elongated, described as pancake or cigar-shaped, defying expectations. So when 3i Atlas shows similar traits, when multiple observers confirm its geometric form, and when official channels stay silent, what are we to think of NASA's response? A carefully worded statement: 3i Atlas poses no threat to Earth. Its trajectory keeps it hundreds of millions of kilometers away, with its closest solar approach on October 30th, before it exits our solar system, never to return. All true. All sidestepping the real question. What is it and why, on the day we should have gotten our clearest view, were 15,000 NASA employees sent home? Chapter 2. The Remote Viewer's Revelation. In August 2025, 2 months before the Mars flyby, before the agency shutdowns and viral expos gripped the world, something extraordinary unfolded in the quiet discipline of remote viewing. It began with Bertie Jorski, a name synonymous with credibility in the field. A former vice president of the Farsight Institute with nearly 30 years of professional remote viewing experience and a master's degree in digital forensics, Bertie is no internet fame seeker peddling wild tales. What she uncovered that summer would shift the narrative around 3i Atlas long before it became a global obsession. A friend provided her with coordinates, nothing more. No context, no images, no hints. This is the essence of true remote viewing. The target remains blind, ensuring no bias taints the process. Bertie entered her protocol, settled into her focused state, and began to describe what she saw. At first it was straightforward, an object moving through space. Ancient, icy, rocky, textbook characteristics of a comet. But then something shifted. It's not entirely natural, she later revealed on a podcast. There's a fingerprint on something that should be pristine. A deliberate signature where randomness should reign. As she delved deeper, Bertie perceived something startling: a small device roughly the size of a thumb drive embedded inside the object, not on its surface, but deliberately placed within. Someone bored into this icy rock, she said, and inserted something encoded with information like an archive. A message in a bottle, but it's more than a message. It's technology. Pause and consider this: not a towering spacecraft or alien beings, but a tiny ancient device hidden inside a comet that's been drifting through the galaxy for billions of years. She emphasized its age, both the comet and the device inside it impossibly old, as if some distant civilization launched a probe to embed their legacy. knowing it would travel forever. This wasn't science fiction. Humanity has done something similar. The Voyager probes carry golden records time capsules designed to endure billions of years, hoping a distant finder might decode them. The concept of using natural objects as cosmic messengers isn't alien to us, we just hadn't imagined it in reverse. After the session, Birdie's friend revealed the target 3I Atlas, an interstellar object still weeks away from making headlines. She had glimpsed something the world didn't yet know existed. Undeterred, Birdie conducted 2 more sessions probing deeper. What she found transformed the picture. It's broadcasting, she reported, not billions of years ago, but now in pulses like a beacon still active. When the podcast host noted that astronomer Avi Loeb had calculated 3I Atlas originated from the same sky region as the 1977 WOW signal, Birdie didn't flinch. "That's super interesting," she said. "It's very possible that's the WOW signal." Remote viewing isn't conventional science. It's subjective, unprovable by traditional standards, dismissed by skeptics, revered by believers, with truth likely lurking in the murky middle. But Birdie wasn't alone. Multiple independent remote viewing groups targeted 3I Atlas after its discovery, and their findings, while varied, echoed haunting consistencies: technology, deliberate placement, broadcasting non-human intelligence. One group sensed humanoid forms tied to the object. Another described graffiti markings or signatures as if someone had claimed it. Several reported the object felt masked, evading full detection as if it didn't want to be seen. More unsettling details emerged: references to crop circles, advanced spherical craft, hybrid warfare, and an invisible war. The phrase brain scanning technology surfaced repeatedly, suggesting capabilities to influence minds or induce mass hysteria. These weren't vague visions, but precise technical impressions resembling intelligence briefings more than psychic musings. One report even mentioned special access and extraction points, hinting at a timetable. Does this prove 3I Atlas is more than a comet? No. Remote viewing remains anomalous cognition, not hard evidence. Yet its consistency across independent viewers with no contact between them is striking, especially when paired with the physical anomalies telescopes later detected. Birdie's vision of a tiny ancient device suggests an object that looks like a comet from afar, ice dust outgassing, but reveals oddities up close. Unusual chemistry, unexpected materials, behaviors that seem engineered. It might be denser than its size suggests, housing something that doesn't sublimate something enduring at its core, and it might be transmitting subtly detectable only with the right instruments at the right moment. Birdie perceived this in August, before the scientific data rolled in, before NASA's silence, before amateur astronomers reported cylindrical shapes and telescopes revealed impossible chemistry. Now, as 3I Atlas slips behind the sun, obscured until December, and as official channels withhold Mars, flyby images or vision of a cosmic message in a bottle grows more compelling. On October 29th, at its closest approach to the sun perihelion, the moment of maximum heat and stress, whatever lies within could either reveal itself or remain hidden forever. As Avi Loeb put it, a moment when confessions are elicited. And the fact that NASA furloughed 15,000 employees, just as we should have gotten our best look, begs the question remote viewers have posed since August. What did they see that were not being shown? Chapter 3: NASA's Deafening Silence. October 3, 2025 was poised to be a landmark day in astronomy, the moment humanity would get its closest look at an interstellar visitor, 3I Atlas, as it passed just 29 million kilometers from Mars. The Mars Reconnaissance Orbiter was perfectly positioned, its HiRISE camera primed to capture images with 30 times the resolution of Hubble's best. ESA's Mars Express and ExoMars Trace Gas Orbiter stood ready with full instrument suites, including high-resolution stereo cameras and spectrometers. Every major space agency on Earth had prepared for months, knowing this was a once-in-a-lifetime chance to study an object from beyond our solar system. And then at the critical moment, NASA vanished. 83% of the agency, 15,000 civil servants, were furloughed, sent home during what should have been the most intensive observation campaign in interstellar astronomy's history. The official explanation: a federal government shutdown due to a budget impasse. Unfortunate timing, they called it. But those 2 words strained to account for why the world's premier space agency went dark, just as an object exhibiting 7 statistical impossibilities sailed past Mars. Consider the odds. 3I Atlas was discovered in July. The Mars flyby planned for months, and yet in the final week before its closest approach, the U.S. government ground to a halt. NASA's website froze. Press releases stopped. The scientists who should have been analyzing data, processing images, and sharing discoveries were sidelined. Only a skeleton crew remained maintaining critical operations. Yet here's the catch: the Mars Reconnaissance Orbiter and Perseverance rover kept working. Raw image feeds from Perseverance continued uploading. The cameras were active, the data was flowing, but none of it reached the public. On October 3rd, an amateur astronomer known as Dobsonian Power, a YouTuber with a solar telescope, posted an image with a stark caption, "What on earth is it?" The image revealed a dark angular shape at 3I Atlas's expected position. Within hours, it racked up thousands of views, with people demanding answers. If a backyard observer could capture this, what were professional instruments seeing? NASA stayed silent. ESA stayed silent. The only official trace of the flyby came from Simeon Schmaus, the astrophotographer, who stacked 20 Perseverance Mastcam Z images and found a faint smudge in Corona Borealis. A private citizen, not an agency, shared what should have been a global scientific triumph. Then came a White House press briefing. Amid discussions of the government shutdown, a reporter posed a question that had been swirling online. Has the president been briefed about 3I Atlas? The room fell quiet. Deputy Chief of Staff Stephen Miller paused, chose his words carefully, and deflected. The briefing moved on, but the question had been asked on camera in an official setting, elevating it beyond internet speculation. The U.S. government was now publicly pressed about an interstellar object and chose not to answer. Meanwhile, astronomer Avi Loeb was relentless, appearing on Newsmax, CBS, and podcasts, laying out the anomalies with surgical precision. The object's trajectory aligned with the ecliptic plane of 0.2% probability. Its timing was optimized for planetary encounters, a 0.005% chance. 7 characteristics set 3I Atlas apart from any known object. Loeb's refrain was clear. We need the Mars orbiter data. The HiRISE images could reveal the nucleus's diameter, resolve its structure, and answer the fundamental question, what is it? Yet those images remained locked away. Loeb wasn't alone. Representative Tim Burchett, a member of the House Committee on Oversight and Accountability, joined him on Newsmax, discussing 3I Atlas and the suspicious silence. A sitting congressman on national television elevating the conversation from fringe to mainstream. Still, NASA said nothing. ESA broke the silence, briefly confirming that Mars Express and ExoMars Trace gas orbiter had observed 3I Atlas between October 1st and 7th. Their instruments, high-resolution stereo cameras, color imaging systems, spectrometers collected data, but results would be published when ready. No images, no preliminary findings, no excitement over capturing an interstellar object at unprecedented range. Just a dry acknowledgement followed by silence. China's Tianwen-1 mission silent. The UAE's Hope orbiter silent. Every spacecraft at Mars had been watching, yet every space agency on Earth had gone mute. You don't need to be a conspiracy theorist to find this odd. Compare it to Oumuamua, the first interstellar comet in 2017, or 2I Borisov in 2019. When Borisov passed through, images poured out immediately. Scientists celebrated, press releases flew, and the astronomical community buzzed with excitement over a rare visitor. It behaved like a comet, predictable chemistry tale and outgassing. It was fascinating but not anomalous. It didn't challenge our understanding or raise uncomfortable questions. 3I Atlas does all of those things. As it vanished behind the sun en route to its October 29th perihelion, the point where no Earth-based telescope can see it, the silence grew heavier. Amateur astronomers shared their final images. Scientists published carefully worded papers avoiding speculation. And 15,000 NASA employees waited to return to work, left to wonder what their essential colleagues saw in those unreleased Mars orbiter images. The question lingers: if 3I Atlas is just a comet, why has the world's greatest space agency chosen silence over celebration? Chapter 4:7 Impossible Things. In science, Occam's razor dictates that the simplest explanation is usually correct. One anomaly might be a fluke too. A coincidence, but 7 statistical impossibilities stacked together. That's when Occam's razor starts carving a different path. 3I Atlas isn't just an interstellar visitor, it's a cosmic enigma defying everything we know. Here are the 7 anomalies that make it unlike anything ever tracked through our solar system. Anomaly 1. The mass problem. When astronomers first estimated 3I Atlas's size based on its brightness, the numbers didn't add up. If its light was purely reflected sunlight, it would span 10 to 20 kilometers massive compared to Oumuamua's 100 meters or 2I Borisov's under 1 kilometer. Statistical models predict we detect hundreds, maybe thousands of smaller interstellar objects before encountering something this large, a 0.01% probability event, or 1 in 10,000. Yet astrometric data from over 4,000 measurements across 227 observatories between May and September revealed something even stranger. Despite outgassing 150 kilograms of material per second, the object's trajectory showed almost no deviation from pure gravitational acceleration. This suggests a nucleus of staggering mass over 33 billion tons, implying a diameter exceeding 5 kilometers, roughly a million times more massive than Oumuamua. It's like comparing a grain of sand to a boulder. Anomaly 2. The sunward glow. On July 21, 2025, Hubble captured the highest resolution image of 3I Atlas, revealing a phenomenon never seen in any comet, solar system, or interstellar. The scattered light around the object extended twice as far toward the Sun as perpendicular, or opposite to it, a 10:1 ratio even more extreme when adjusted for viewing geometry. Comets' tails point away from the Sun due to radiation pressure, a principle confirmed by centuries of observations. 3I Atlas defies this, its glow stretching sunward in a way that breaks basic physics. Avi Loeb and Eric Kato proposed a model involving ice fragments sublimating at different rates based on ejection direction. The math holds, but it demands a unique configuration never observed in any other comet, conveniently aligning with an object already riddled with anomalies. Anomaly 3. The industrial fingerprint. In late August, the Very Large Telescope in Chile aimed its UVES spectrograph at 3I Atlas and detected something chilling: nickel atoms in the gas plume rising exponentially by a power law of 9 as the object neared the Sun, but almost no iron accompanied it. In nature, nickel and iron form together in supernovae, appearing in fixed ratios in every natural comet from 2I Borisov to solar system bodies. 3I Atlas's nickel-heavy, iron-scarce signature mirrors. Industrial alloys, materials refined and separated deliberately. Scientists called it extremely puzzling, noting that the object's distance from the Sun was too far for refractory minerals to vaporize under normal conditions. Their proposed chemical pathways felt like grasping at straws. Anomaly 4. Polarization from another world. Light scattering off particles reveals their size, shape, and composition through polarization. Comets have predictable polarization signatures cataloged across hundreds of observations. 3I Atlas's signature is alien. 2.77% polarization at a 7-degree phase angle with a 17-degree inversion angle, a combination unseen in any asteroid or comet. The closest match isn't comets but trans-Neptunian objects in the Centaur Pholus icy bodies with vastly different compositions. A paper in Astrophysical Journal Letters labeled 3I Atlas, a distinct type of comet, scientific shorthand for we have no category for this. Anomaly 5. Ecliptic alignment. The solar system's planets orbit in a flat plane called the ecliptic. Random interstellar objects should cross this plane at random angles with a 0.2% chance 1 in 500 of aligning within 5 degrees. 3I Atlas arrived perfectly aligned, moving retrograde opposite the planet's orbits. This trajectory is ideal for surveying multiple planets with minimal course corrections, almost as if designed for efficiency. Anomaly 6. Planetary timing. 3I Atlas's path brings it close to 3 planets: Venus at 0.65, AU Mars at 0.19, AU and Jupiter at 0.36 AU. The odds of a random interstellar visitor timing its flyby to pass so near 3 planets, a staggering 0.05% or 1 in 20,000 sellers. If you were plotting a reconnaissance mission through our solar system, this is the path you'd choose. Anomaly 7. The WOW signal coincidence. In 1977, the Big Ear radio telescope detected a 72-second signal from Sagittarius so extraordinary that astronomer Jerry Amon scrawled "wow" in the margins. Despite decades of searching, it was never detected again. When scientists traced 3I Atlas's trajectory backward, accounting for its speed and direction, it originated within 9 degrees of the WOW signal source, a 0.6% probability alignment. 7 anomalies, each a statistical longshot, pile up to challenge the notion of coincidence. As 3I Atlas approaches perihelion hidden behind the Sun, these impossibilities demand an answer. Is this merely a comet, or something far stranger defying Occam's razor and rewriting our understanding of the cosmos? Chapter 5. October 29th. The Confession. Somewhere beyond our reach, cloaked in the blinding veil of the Sun, 3I Atlas races toward a moment of cosmic truth. On October 29, 2025, at approximately 1.4 astronomical units just inside the orbit of Mars, this enigmatic interstellar traveler will reach perihelion, its closest encounter with our star. Here, the Sun is no longer a distant beacon but a relentless inferno, its heat and radiation an overwhelming force hammering the object with gigawatts of raw energy enough to power entire cities. Imagine standing before an open blast furnace, then multiply that intensity by a factor beyond human comprehension. This is the crucible of perihelion, where pretenses are burned away, and the true nature of 3I Atlas will be laid bare. As Aviv, the renowned physicist, once observed, high-stress environments extract confessions. He spoke of interrogation tactics, but the principle holds equally true in the unforgiving realm of physics. Heat ice and it melts into its honest form. Heat rock and it reveals its unyielding essence. Heat something masquerading as a comet, something that might be far more, and the mask will slip. Perihelion is the ultimate interrogator, and on October 29th, 3I Atlas will face its trial by fire. 2 vastly different fates await each with profound implications. In the first scenario, 3I Atlas is precisely what it appears to be, a comet, albeit an extraordinary one. Massive, chemically peculiar, and statistically improbable, it is nonetheless a natural relic of the cosmos. If this is true, October 29th will mark the beginning of a celestial spectacle. As solar radiation bathes its surface, temperatures will soar, awakening volatiles frozen for billions of years. Carbon dioxide will sublimate into gas. Water ice will vaporize and dust will erupt in towering plumes, forming a tail that could stretch millions of kilometers across the void. We've seen comets transform at perihelion before brightening dramatically, their tails unfurling like cosmic banners, sometimes fracturing under the strain into fragments that scatter in chaotic, mesmerizing beauty. If 3I Atlas is a comet, its 5-kilometer form, potentially a fragile lattice of ice rather than solid rock, could erupt in a dazzling outburst of gas and dust, its brightness surging by tenfold or more. A proper cometary tail, not the strange sunward glow we've observed, would stream behind it, sculpted by the relentless push of solar radiation. If the object is as delicate as some scientists speculate, perihelion might tear it apart entirely, offering an unprecedented glimpse into the internal structure of an interstellar comet. Such an event would be a scientific treasure trove, answering questions about the formation of comets, the chemistry of distant star systems, and the violent processes that fling objects into the interstellar abyss. Even if 3I Atlas disintegrates, its destruction would be a gift to science, a fleeting but radiant window into the universe's deep past. But there is another possibility, one that chills the blood and challenges our understanding of the cosmos. What if 3I Atlas is not a comet at all? Its anomalies, the absence of iron in its nickel-rich composition, the bizarre backward tail, the uncanny alignment with the ecliptic, and the origin of the 1977 WOW signal are too precise to dismiss as mere coincidence. In this second scenario, perihelion is not a moment of destruction but of awakening. Imagine you're an advanced civilization sending a probe across the stars. It must survive billions of years in the freezing, radiation-battered void, enduring micrometeorite impacts and the slow decay of time. Encasing it in ice is a stroke of genius. Ice is abundant, protective, and camouflages the probe as a natural object invisible to prying eyes until it's ready to reveal itself. When that probe reaches the inner solar system, it needs power to activate, and the star provides the only source. Perihelion in this scenario is not a stress test, it's a charging station. Dr. Lowe, in his meticulously detailed papers, laid out the possibilities with mathematical rigor. 3i Atlas could execute a solar orbit maneuver, a technique our own spacecraft used to harness a star's gravity, accelerating and redirecting trajectory with minimal fuel. Perihelion, hidden from Earth's telescopes behind the sun's glare, is the ideal moment for such a maneuver, undetected, untraceable. Alternatively, it could release smaller probes, miniature craft detaching to intercept nearby planets Mars, Earth, or Jupiter, taking advantage of their near-perfect alignment in late 2025. This alignment makes such trajectories almost trivially achievable compared to random arrival times. Lowe's warnings were stark. If 3i Atlas emerges from perihelion on a course toward Earth, the consequences could be catastrophic, not physically but socially and economically. Financial markets could collapse under the weight of humanity's realization that we are not alone, and the visitors might not come in peace. This is not sensationalism, it's a calculated assessment of how societies react to existential uncertainty. For now, we are blind. From late October to early December 3rd, Atlas remains obscured behind the sun, beyond the reach of every Earth-based telescope and space observatory. This blackout is a perfect cloak for a craft that wishes to conceal its next move. But humanity is not entirely helpless. The European Space Agency has a contingency plan. Between November 2 and 25, the Jupiter Icy Moons Explorer JUICE, en route to study Jupiter's moons, will pivot its instruments toward 3i Atlas. JUICE, designed to probe icy worlds and analyze alien oceans, is not optimized for comets, but its cameras and spectrometers can capture critical data. Positioned between Earth and the Sun, JUICE has a unique vantage point unobstructed by the solar glare that blinds us. If 3i Atlas erupts into a comet's fiery display, JUICE will see the massive coma and tail. If it fragments, JUICE will map the debris field. And if it does something no comet could, maneuvering, releasing objects, or betraying any sign of artificial behavior, JUICE will record that too. The data will take time to reach us. Space communication is slow, and JUICE is far from Earth. But by late November or early December, the first answers will arrive, just as 3i Atlas re-emerges into Earth's view. On December 19, 2020, 3i Atlas will make its closest approach to our planet, still a safe 1.8 astronomical units away, but near enough for every major observatory to track its path with exquisite precision. If its orbit aligns perfectly with gravitational models, we can breathe a collective sigh of relief, just another interstellar wanderer, strange but natural, passing through on its journey back to the cosmic dark. But if the numbers are off, if the trajectory shows even the slightest deviation that cannot be explained by outgassing or solar radiation pressure, everything we believe about our place in the universe will demand re-evaluation. October 29th is the day 3i Atlas confesses its true nature, whether comet or something far stranger. We won't hear that confession until December, when the data from JUICE and our observatories converge. By then, it may be too late to do anything but watch, wait, and brace for what comes next. The universe is holding its breath, and so are we. Chapter 6. The Global Firestorm. While scientists wrestled with data and NASA maintained a cryptic silence, a different force was gathering momentum, one that outpaced the meticulous pace of peer-reviewed papers. The internet had ignited a wildfire of speculation and fear, spreading faster than any telescope could track. It began as these things often do in the United States. TikTok videos claiming to show 3i Atlas flooded feeds, some capturing grainy but genuine telescope footage. Others brazenly fabricated, racking up millions of views. Reddit threads ballooned into sprawling debates, thousands of comments deep, while X, once called Twitter, became a battleground. Amateur astronomers shared legitimate observations, their posts drowned out by influencers peddling wild claims for clout. America was merely the spark. In India, the phenomenon morphed into something far more chaotic. WhatsApp, the lifeblood of communication for hundreds of millions, became a superhighway for rumors that outran fact-checkers' efforts. Messages in Hindi warned of an alien ship cloaked as a comet, complete with breathless voiceovers, and fake screenshots of news articles engineered to terrify. One viral forward claimed world leaders were secretly negotiating with whatever or whoever was aboard 3i Atlas. Another alleged covert military mobilization. A particularly insidious post circulated an edited NASA image stamped classified, depicting a geometric structure where the comet should have been. None of it was true, yet all of it spread like wildfire. Hindi-language YouTube channels fueled the frenzy, some earnestly explaining interstellar objects, others weaving astronomy with ancient astronaut theories and apocalyptic prophecies. The boundary between education and sensationalism dissolved entirely. Brazil's digital landscape mirrored this chaos with Telegram and Facebook as the epicenters. UFO enthusiast communities long accustomed to scrutinizing lights over the Amazon now had a tangible target, an interstellar object with behaviors that baffled even scientists. Brazil's conspiracy culture, a vibrant tapestry of indigenous mythology, Catholic mysticism, and modern UFO lore, embraced 3i Atlas as a multifaceted symbol. To some it was an apocalyptic harbinger, to others a vessel carrying enlightened beings to redeem humanity, to yet others a weapon, a gift, or a cosmic test. Facebook groups swelled with new members and live streams stretched for hours, hosts reading scientific papers before pivoting to speculation that soared far beyond the data. Comment sections became digital campfires where thousands gathered to share theories, fears, and fervent hopes in equal measure. In the United Kingdom, with its storied history of crop circles and UFO investigations, 3i Atlas was met with a blend of skepticism and fascination. Tabloids crafted headlines that danced on the edge of sensationalism while maintaining plausible deniability. Massive comet could be alien tech, scientists say. The scientists were often avidly quoted out of context, but the headlines did their work stoking intrigue. Russia, meanwhile, viewed the phenomenon through a geopolitical lens. State media mentioned 3i Atlas, sparingly framing it as a Western problem, hinting at American confusion or even cover-ups. Some outlets suggested the U.S. knew more than it let on, perhaps tied to secretive black budget programs. Russian-language forums buzzed with surprisingly sophisticated astronomical discussions, but these were laced with theories linking 3i Atlas to recovered alien technology or Soviet-era conspiracies. Then came the Mikio Kaku incident. A screenshot began circulating showing the famed physicist in what appeared to be a TV interview, with text claiming he'd declared 3i Atlas a reconnaissance probe possibly hostile. The caption screamed, "It might be an alien probe sent to Earth." The image was real. The context was not. Fact-checkers traced it to a national news interview from February 20, 2025, months before 3i Atlas's discovery, where Kaku discussed an unrelated asteroid scenario. Someone had doctored the image, slapped on false text, and unleashed it online. The truth didn't matter. The post amassed over 290,000 views before platforms flagged it, and by then it had been screenshot and reshared beyond tracing. The account behind it, Lord Bebo, never retracted. The damage was done. Thousands now believed a respected physicist had confirmed 3i Atlas as hostile alien tech. NASA tried to quell the storm. On September 30th, their official solar system account posted Comet 3i Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away. This is a natural interstellar object, rare, scientifically valuable, but not dangerous. The response was swift and scathing. If it's just a comet, why the secrecy? If it's safe, why the silence? Explain the nickel without iron. NASA offered no follow-up, their lone post a frail bulwark against a tidal wave of doubt. Al Jazeera's fact-checking arm, Sanad, published a meticulous report confirming 3i Atlas's discovery by the Atlas telescope on July 1, 2025, and its safe distance of 270 million kilometers at closest approach. They debunked the Kaku quote, the military rumors, and the negotiation claims. It was exemplary journalism. It changed almost no one's mind. Amid the digital chaos, Aviblo was quietly making waves at the United Nations, not in the General Assembly, but in hushed conversations with delegates and papers passed to policy advisors, in meetings where existential was uttered without irony. He presented his Black Swan scenario, a concept borrowed from Nassim Taleb's work on improbable high-impact events that seem impossible until they occur, then inevitable in hindsight. Lowe argued that we assume all interstellar visitors are natural because that's all we've known. But what if that assumption fails? A single non-natural object could rewrite our understanding of the universe and our place in it. The hashtag, the harbinger, began trending not in mainstream feeds but in niche communities obsessively tracking 3i Atlas. The term, drawn from ancient prophecies of skyborne messengers heralding change or judgment, resonated deeply. For some, it was literal, an end-times omen mapped onto an object with impossible traits. For others, it symbolized a new space age, a wake-up call to a universe far more crowded than we dared imagine. Through the noise, one name kept surfacing: Stephen Burns, the cosmologist Moneypenny had referenced. Whispers claimed Burns believed 3i Atlas was intelligent, even conscious, communicating with Earth and other planets. No one could pinpoint a source, no papers, no interviews. Just vague social media posts and second-hand accounts. Yet the idea took root, fitting too neatly with the anomalies, the silence, the growing sense that something monumental was unfolding just beyond our grasp. The world was no longer just watching the skies. It was spiraling into a collective fever. Dream equal parts fear, wonder, and uncertainty as 3i Atlas held us all in its silent, unseen thrall. Chapter 7, December's Verdict. In early December 2025, 3i Atlas will pierce the sun's blinding curtain, emerging like a cosmic voyager surfacing from an abyss. Astronomers will track it in the constellation Virgo, a faint glimmer low on the pre-dawn eastern horizon, glowing at magnitude 12 or 13, too dim for amateur scopes, but a beacon for the world's most powerful observatories. Every lens will be trained on it, every scientist and enthusiast poring over the numbers, for orbital mechanics is humanity's sharpest predictive tool. Newton's laws honed by Einstein's relativity map an object's path years in advance, pinpointing its position to within a kilometer. We can account for the gravitational pull of planets, the subtle nudge of solar radiation, even the faint push of outgassing as comets shed their frozen skin. When 3i Atlas reappears, its position will weave a tale, one that either anchors our understanding or unravels it entirely. If 3i Atlas sits exactly where gravitational models place it, with only minor deviations from expected outgassing, we can infer that its journey behind the sun was unremarkable. It weathered the blistering heat of perihelion on October 29, 2025 at 1.4 astronomical units, and continued its predetermined trajectory bound for the outer solar system, and ultimately the interstellar void. This would mark it as a natural object, however strange, a comet forged in an alien star system. Its anomalies a product of unfamiliar chemistry or physics, but nothing more. Yet if its position deviates, if its trajectory betrays changes that no known force can explain, every study of 3i Atlas will demand a radical revision. In the cosmos, objects don't swerve without cause. Something or someone must act upon them. The Vera C. Rubin Observatory, a titan of modern astronomy, will be central to this moment. Newly operational in 2025, its capabilities are staggering. Where older surveys cataloged 20,000 asteroids annually, Rubin identified 2,140 in its first 10 hours of operation. 10 hours, 2,000 asteroids, a glimpse of its power to rewrite our view of the skies. When tasked with hunting interstellar objects, Rubin could transform a rare event into a routine discovery, potentially spotting dozens of cosmic visitors each year, instead of one every few years. Each will be dissected with the lessons of 3i Atlas in mind: chemical signatures, polarization patterns, orbital alignments. If 3i Atlas is truly anomalous, Rubin will seek its counterparts, determining whether it's a lone outlier or the harbinger of a new class of objects. This telescope, with its unprecedented ability to scan the heavens, will ensure that 3i Atlas is not studied in isolation but as a benchmark for what's to come. December, however, is not solely about orbits and future surveys. It's about confronting questions that have haunted us since the object's discovery in July. What did the Mars orbiters capture? By December, the government shutdown that paralyzed NASA will be a distant memory, the agency fully staffed and operational. The high-resolution images from October 3rd, taken when 3i Atlas was a mere 29 million kilometers from Mars's cameras, will have been processed, scrutinized, and either archived or readied for release. At that distance, a 5-kilometer object should reveal its form. Round, elongated, or irregular variations in brightness could betray a patchwork of surface materials from icy crust to rocky outcrops. Does it mirror the pitted, jagged nuclei of comets like 67P, Churyumov, Gerasimenko, photographed by Rosetta, or does it present something alien to our experience? The silence surrounding these images is deafening. Science thrives on rapid disclosure. The race to publish relentless. That multiple space agencies, NASA, ESA, and others observed 3I Atlas at Mars yet withheld detailed imagery suggests either an improbable global pact or findings so profound they require delicate handling before public release. December will demand resolution. Either the images emerge painting 3I Atlas as an unusual but natural comet, or their continued absence will speak louder than any press release. The lack of transparency fuels speculation amplified by the global frenzy that erupted in recent months. The internet from TikTok to WhatsApp has spun tales of alien probes and secret negotiations, and the absence of hard data only pours fuel on the fire. If the images show a comet's familiar chaos, craters, jets, or fractures, we may quell the rumors. But if they reveal something else, a structure too regular, a surface too uniform, or behavior too precise, the silence will take on a new unsettling weight. Radio astronomers, too, will be on high alert, drawn by the tantalizing link to the 1977 WOW signal. Telescopes worldwide, from Arecibo's successors to the square-kilometer array's precursors, have been quietly monitoring the region where 3I Atlas will appear. This is no SETI spectacle with public fanfare, but a disciplined, methodical watch. Any signal, a pulse, a pattern, or any anomaly tied to the object's position would be seismic. The hydrogen line at 1420 MHz, where the WOW signal briefly blazed, is the frequency of choice, a cosmic standard tied to the universe's most abundant element. Any civilization aiming to broadcast would choose this channel, a universal beacon for those listening. If 3I Atlas is more than a comet, if it carries a message, this is where it will speak, and December offers a fleeting window to hear it. On December 19th, 3I Atlas will reach its closest approach to Earth. 1.8 astronomical units, or roughly 270 million kilometers, about 1.5 times the Earth-Sun distance. Safe by any practical measure, yet close enough for parallax to sharpen our view. This apparent shift in position observed from different points on Earth's orbit enables precise triangulation of distance and velocity. Observatories spanning the globe, northern and southern hemispheres, from Hawaii to Chile, Australia to South Africa, will synchronize for continuous coverage. Amateur astronomers armed with increasingly sophisticated equipment will join professionals feeding data into a collective effort that may become the most exhaustive observation of a solar system object in history. Every pixel, every measurement will be scoured for clues. The data will hold the truth confirmation that 3I Atlas is a natural interstellar visitor, its quirks explained by the exotic conditions of its origin or contradiction, a trajectory, chemistry, or behavior that defies the laws we know. A single unexplainable deviation, a course correction too precise, a signal too structured, or a shape too artificial could force us to reconsider our place in the cosmos. By late December 3rd, Atlas will begin to fade, drifting into the constellation Leo as it recedes from the Sun. It will pass Jupiter's orbit in March 2026, then slip into the heliosphere's outer reaches, bound for the interstellar dark. December will not answer every question, but it will provide enough to know whether we're witnessing the most spectacular comet of our generation, or the most profound shift in human understanding, since Copernicus displaced Earth from the universe's center. The telescopes are calibrated, the equations polished, the world poised on a knife's edge. Social media hums with anticipation, from Gates, the harbinger, to whispered claims of Stephen Burns' unverified theories of intelligent design. The stakes are existential, the outcome uncertain. All that remains is for 3I Atlas to emerge from the sun's shadow and declare in the cold language of data what it truly is. Chapter 8. The Scientific Impossibilities. Let me pull you deeper into the anomalies that have astronomers staring at their screens until dawn. Not the feverish speculation swirling across social media, but the raw, unyielding data that refuses to align with our models no matter how many iterations we run. These are the measurements that whisper of something beyond the natural, forcing even the most skeptical minds to confront the uncomfortable. We begin with the WOW signal, a phantom from the past that now seems to echo into our present. On August 15, 1977, the Big Ear radio telescope at Ohio State University was methodically scanning the heavens in a routine SETI sweep when it captured something inexplicable. a narrowband emission at precisely 1420.4 MHz. The hydrogen line, the frequency any advanced civilization might choose, is a cosmic handshake tied to the universe's most abundant element. The signal endured for exactly 72 seconds, the precise span of the telescope's beam, as Earth's rotation swept it across a fixed point in the sky. Its strength was staggering 30 times the background noise, a spike that leapt from the printout's routine 1s and 2s to 5s, 6s, and finally, U, the system's alphanumeric limit, shorthand for unknown, or simply off the charts. Young astronomer Jerry Amon spotted the ascent and scrawled a single word in the margin: "Wow." For decades the hunt continued. Big Ear returned to that Sagittarius patch hundreds of times. Observatories worldwide joined the chorus. Silence. The signal never repeated, fading into legend as astronomy's greatest unsolved riddle, a tease of intelligence, proof of nothing yet indelible. Until now. Rewind. 3I Atlas's path through the galaxy at its interstellar velocity of 60 km/s. In 1977, it would have hovered roughly 600 astronomical units from Earth, 90 billion kilometers distant, 600 times farther than the Sun. To punch through that void with a signal 30 times above noise would demand a transmitter wielding 0.5 to 2 gigawatts. That's no solar panel or chemical battery. That's a nuclear heart beaming coherent energy in a laser-like focus across interstellar gulfs. Could a comet muster that? No physics we know allows it. Comets don't forge gigawatt pulses or tune to universal beacons. They don't whisper once and vanish, preserving stealth until arrival, but a probe crafted to announce itself at the system's edge, then fall silent might. A deliberate ping, unmistakable yet ephemeral, buying time to close the distance undetected. Shift now to the chemistry revealed by the Very Large Telescope's unblinking gaze. Nickel pristine and abundant but utterly devoid of iron. In nature's forge, these siblings are inseparable twins born in supernova crucibles, where massive stars erupt, fusing heavy elements in cataclysmic fury. Nickel 56 decays to iron 56, locked in the same stellar debris woven into minerals scattered across the cosmos. Every meteorite, asteroid, comet we've dissected, from solar system wanderers to interstellar kin, like 2I Borisov, bears them in tandem. Ratios fluctuate with cosmic locales, but absence impossible. No natural process at 3I Atlas's frigid temperatures or gentle solar heating could cleave them apart. Yet refinement can. Smelting, electrolysis, industrial extraction. The hallmarks of deliberate metallurgy strip iron impurities for high-purity nickel in electronics, alloys, reactors. We perform this alchemy daily on Earth, leaving a telltale void: nickel without iron. The VLT team exhausted every naturalistic alibi: anomalous ice chemistry, exotic minerals from unseen stellar nurseries, dust grain sorcery. Each crumbled against the data. Temperatures too low, environments mismatched. This defies equilibrium, and it's dynamic. As 3I Atlas nears the Sun, nickel emissions surge exponentially, following a power law exponent near 9. A tenfold proximity hike yields steep, non-random escalation. Not erratic venting, but a calibrated ramp-up, as if systems awakening to stellar fuel. Then the tale that defies the stars. Radiation pressures, planetary science's simplest axiom, photons, battered dust grains imparting relentless momentum. That gravity can't counter, sculpting tails to stream eternally anti-sunward. Every comet we've imaged obeys this Halley-Hale-Bopp Borisov trails flowing outward like solar wind banners. Except 3I Atlas. Hubble's unflinching stare shows scattered light extending twice as far sunward as away. A bidirectional plume, where physics insists on one-way flow. Data enhancements sharpen the heresy, more material forward than aft. Avive and Eric Keto's model salvages plausibility with a razor-thin premise: sun-facing ice shards eject preferentially their bulk-resisting radiation, while scattering light, forging a forward snow line under hyperspecific heating and velocity. The math holds barely. Day-side bias, fragment sizing for optimal persistence, evaporation tuned to perfection. It's conceivable, like flipping heads 50 times in a row. Lawful, but improbably exquisite. A weighted die. The anomalies compound. Excessive mass invoke improbable density. Ecliptic alignment. A fluke. Polarization quirks novel dust geometries. Each stands alone as a stretch. Together 7 improbabilities in one object strain credulity. When does rare natural yield to engineered intent? This is the riddle gnawing at scientists as 3i Atlas conceals itself behind the sun, its confessions deferred to December, but October 2025 offers no respite. The skies above brim with fresh enigmas, as if the cosmos conspires to unsettle us further. On October 1st, an unheralded intruder asteroid 2025, TF, a car-sized rock, slipped through our vigilant nets, hurtling past at 13,000 np, a mere 250 miles above the South Pole. That's ISS altitude, where satellites swarm in tracked ballet. Yet this phantom evaded detection until 6 hours post-flyby, spotted by Kit Peake's Bach telescope. A near miss in humanity's orbital backyard, underscoring our fragile watch over the void. Meanwhile, on Mars, Perseverance's unyielding gaze unearthed what may be the starkest relic of antiquity, yet leopard spots, etched in Jezero crater's mudstones, iron-rich nodules of vivianite and greigite minerals birthed by microbial feasts on organics in low-oxygen waters. Frozen in 3-billion-year-old sediment, these patterns scream of life in a wetter epoch, the rovers Sherlock and Pixel instruments mapping reactions too intricate for abiotic chance. Not proof, but the sharpest hint we've grasped that the red planet pulsed with biology. Across the globe, congressional chambers echoed with Yemen's Shadow War declassified footage from October 30th, 2024, shows an MQ-9 Reaper unleashing a Hellfire missile at a luminous orb skimming the coast. Impact registers debris shears, yet the object endures, tumbling onward unscathed. No earthly craft withstands such kinetic fury. Witnesses testify to tech beyond our arsenals, reigniting UAP scrutiny amid Houthi drone swarms. Our sun, too, stirs in its twilight throes. Solar Cycle 25 crests toward a last gasp, a turbulent finale in the declining phase where rogue sunspot clusters unleash flares, and coronal ejections fiercer than the maximum's roar. Expect auroras ablaze, rivaling decade spectacles as late cycle surges paint mid-latitudes in ethereal fire through 2026-2027, compounding the celestial barrage. 3 comets converge: C-I 2025, A6 Lemon, and C-2025, R2 Swan Streak, green tinged toward perihelion, their carbon comas fluorescing under solar blaze, poised for naked eye brilliance by late October. A third trails turning verdant as it nears harbingers visible without aid if skies oblige. Yet amid this frenzy, NASA's gears grind to a halt. 15,000 furloughed in the government's shutdown spasm. 83% of the workforce idled as budgets deadlock. Science freezes, data pipelines stall even as China vaults toward lunar primacy. Meanwhile, a private titan rises SpaceX's Starship, the mightiest rocket forged readies its pivotal test redesigns, etched from explosive lessons chasing orbital dominion and Mars's red embrace. This isn't fiction. This is October 2025, the veil thinning between the routine and the revelatory. If the anomalies of 3i Atlas probe designs edge, these headlines herald a universe insistent on revelation. Dive deeper if you dare, like, subscribe. Share your shocks below, from where, at what hour, which tale grips you most, the skies. Demand witnesses. Let's unpack this generational upheaval thread by thread, as the stars refuse to stay scripted. Chapter 1. Close Encounter. The asteroid that outwitted us. Humanity has invested billions to shield Earth from cosmic threats, constructing an intricate planetary defense system that rivals the ingenuity of our greatest achievements. Telescopes dotting the globe from remote mountaintops to sprawling observatories sweep the heavens night after night, meticulously cataloging every glimmer, every speck that dances across the stars. These sentinels calculate trajectories with surgical precision, ensuring no catastrophic asteroid catches us unaware. For massive rocks, those capable of obliterating cities or even rewriting the fate of civilizations, our system is a triumph, spotting them months, sometimes years in advance. But on October 1st, 2025, this formidable network was blindsided by a stealthy interloper that slipped through the cracks, exposing a vulnerability we can't ignore. Asteroid 2025 TF, a compact cosmic wanderer, measuring between 1.2 and 2.7 meters in diameter, roughly the size of a small car barreled through space at a staggering 20.9 kilometers, or nearly 13,000 miles per hour. To grasp its speed, imagine a rock crossing the entire United States in less than 4 minutes, a fleeting blur against the cosmic backdrop. At its closest approach just after midnight, UTC on October 1st, this unassuming asteroid grazed Earth at a mere 419 kilometers above Antarctica's icy expanse. That's the same altitude where the International Space Station orbits, a fragile outpost where astronauts drift in sleep, blissfully unaware of the celestial trespasser passing through their neighborhood. The Catalina Sky Survey in Arizona, a cornerstone of our asteroid tracking efforts, finally detected 2025 TF at 2:35 a.m. Eastern Time, using the powerful Bok telescope at Kitt Peak National Observatory. But the discovery came with a gut-punch realization: it was detected 6 hours and 36 minutes after its closest approach. We didn't see it coming. We saw it leaving a fleeting shadow, already retreating into the void. This near miss earned 2025 TF the chilling distinction of being the second closest asteroid flyby ever recorded, outdone only by 2020 VT4, which slipped within 370 kilometers of Earth's surface in November 2020, also spotted after the fact. A disturbing pattern is emerging, one that underscores a blind spot in our cosmic vigilance. This isn't a failure of human skill or dedication. The astronomers and engineers behind these systems are among the finest minds on the planet, wielding cutting-edge technology to safeguard our world. The true obstacle lies in the unforgiving laws of physics and the limits of our resources. Small asteroids like 2025 TF are maddeningly elusive. Dark, fast, and barely reflective, they blend into the inky blackness of space, evading even our most advanced telescopes. Our detection networks are finely tuned to catch the giant asteroids larger than 150 meters, capable of unleashing regional devastation. These we track with relentless precision, plotting their paths years in advance. But the millions of smaller objects ranging from 1 to 10 meters, they're like needles in a cosmic haystack, nearly invisible until they're practically upon us. When 2025 TF was finally spotted, scientists raced to unravel its secrets, working backward to map its journey through the solar system. Their calculations revealed an elongated orbit around the Sun, with a semi-major axis of 1.62 astronomical units. At its closest, it dips to 0.676 astronomical units from the Sun at perihelion, then swings out to 2.56 astronomical units at aphelion. Its orbital period spans roughly 2.06 years, tilted at a 9.1 degrees angle relative to the ecliptic plane, the flat disk where most planets trace their paths. But these numbers are shrouded in uncertainty. Based on a mere one-day observation arc, the orbit carries a condition code of 7, a technical term for what amounts to educated guesswork. Predicting where 2025 TF will go next is like trying to chart a ghost path through a storm. More observations are essential to refine its trajectory and determine if it poses a future threat or if it will vanish into the cosmic deep end, never to return. This uncertainty is unsettling. An object passed closer to Earth than some of our own satellites, yet we know so little about its origins or its next move. It could be on a collision course decades from now, or it might never come near us again. We simply don't know. What we do know is that asteroids of this size aren't rare visitors. The 1908 Tunguska event, which flattened 830 square miles of Siberian forest in a cataclysmic explosion, was likely caused by an object just 30 to 50 meters across, larger than 2025 TF, but not by an insurmountable margin. Had 2025 TF veered onto a collision course instead of a flyby, it would have erupted in the atmosphere with the force of several kilotons of TNT. Not enough to end the world, but more than enough to devastate a city if it detonated overhead. And we would have been clueless until the sky lit up. This close call is a stark wake-up call, reigniting urgent discussions about bolstering our ability to detect smaller near-Earth objects. Our cosmic neighborhood is a bustling, hazardous place, teeming with millions of these small, elusive rocks. Our current systems, as advanced as they are, can't fully keep up. The question isn't whether another asteroid will slip through our defenses, it's when, and whether we'll be fortunate enough for it to miss again. Scientists are sounding the alarm, pushing for enhanced telescopes, better algorithms and more resources to close the gap in our planetary shield. Yet as we grapple with the dangers lurking in the skies above, something far more profound is unfolding on the red plains of Mars. Whispers of a discovery are emerging, one that could answer one of humanity's oldest and most haunting questions, shifting our gaze from the threats above to the mysteries beyond. Chapter 2: The Mars Breakthrough. A glimpse of ancient life. For over a year, a single rock on Mars has haunted the dreams of scientists worldwide, not for its size or makeup, but for the enigmatic patterns etched upon its surface. These markings, if found on Earth, would be heralded as unmistakable fingerprints of life. On September 10, 2025, NASA dropped a bombshell that reverberated through the scientific community and captivated the world. The Perseverance rover's discovery of potential biosignatures in a sample dubbed Sapphire Canyon had endured the most exhaustive scrutiny imaginable, culminating in a peer-reviewed publication in the prestigious journal Nature. Acting NASA Administrator Shaw Duffy didn't mince words. This could very well be the clearest evidence of life we've ever found on Mars. Let's rewind to July 24, 2024, when Perseverance's drill bit into an arrowhead-shaped rock nicknamed Chayava Falls, nestled within Mars' Jezero crater. The rover's instruments immediately flagged something extraordinary. The rock's surface was adorned with what scientists dubbed leopard spots, small circular features with pale centers ringed by darker edges. These weren't mere geological curiosities. They bore chemical signatures that on Earth are often forged by microbes, consuming organic matter and excreting specific minerals as byproducts. The leopard spots revealed the presence of vivianite and gregoite, two minerals that thrive in low-temperature water, rich environments. Vivianite, a hydrated iron phosphate, is commonly found near decaying organic matter in terrestrial sediments. Gregoite, an iron sulfide, is a telltale byproduct of certain microbial metabolisms. The discovery of these minerals coexisting alongside organic carbon forms what geologists call a compelling potential biosignature, a tantalizing clue that demands further exploration. But the story grows even more gripping when you consider the rock's location. Chayava Falls lies within the Bright Angel Formation, a geological marvel along the edges of Neretva Vallis, an ancient river valley that once funneled water into Jezero crater over 3 billion years ago. This valley, roughly a quarter-mile wide, speaks of a Mars sculpted by powerful, sustained river flows, interspersed with tranquil periods of standing water. Such dynamic settings on Earth are teeming with microbial life, thriving in the ebb and flow of wet and dry cycles. What stunned scientists was that Bright Angel's rocks are among the youngest sedimentary layers Perseverance has explored. Earlier theories pinned hopes for ancient life on Mars' oldest formations, relics of its wettest, most habitable era. Yet finding these features in relatively younger rocks suggests Mars may have remained a haven for life far longer than we dared imagine, or that life clung tenaciously to existence as the planet dried out. Let's be clear, a potential biosignature is not proof of life. It's a beacon calling for deeper investigation. As mission scientist Katie Stack Morgan emphasized, claims of past extraterrestrial life demand extraordinary evidence. The Nature publication was the result of a grueling year-long peer review process with independent scientists dissecting the Mars 20 team's data for any non-biological explanation. While some alternative processes like chemical reactions in water-rich environments could theoretically mimic these patterns, none match the evidence as convincingly as the biological hypothesis. The power of this discovery lies in the precision of Perseverance's tools. The rover's Sherlock instrument, scanning habitable environments with Raman and luminescence for organics and chemicals, detected a strong spectral signal known as the G-band, a hallmark of organic carbon. Meanwhile, PIX-L planetary instrument for X-ray lithochemistry mapped the chemical elements across the rock's surface with pinpoint accuracy. Together, they revealed something remarkable. The organic matter and redox-sensitive minerals weren't just present, they were intricately co-located within the leopard spots, clustered in a way that mirrors microbial activity on Earth. In terrestrial settings, bacteria consume organic compounds, releasing minerals that precipitate right where the microbes thrive, forming distinctive patterns. The leopard spots on Chayava Falls bear an eerie resemblance to features in Earth's ancient rocks where microbial life left its mark eons ago. But there's a catch, one that looms large. Confirming whether these features are truly biological requires bringing the Sapphire Canyon sample back to Earth. Only in terrestrial laboratories equipped with instruments far beyond a rover's capabilities can scientists perform isotopic analysis, probe the molecular structure of the organic compounds, and conduct experiments to unravel the truth. This is where the story takes a dramatic turn, veering into the realm of politics and ambition. The Mars Sample Return Mission, a collaborative effort between NASA and the European Space Agency, was designed to retrieve Perseverance's carefully collected samples and deliver them to Earth's labs. But the mission has been battered by soaring costs and endless delays. President Trump's proposed 2026 budget threatens to axe the program, entirely slashing its funding to zero. During the September press conference unveiling the Chayava Falls findings, Shaw Duffy framed this not as abandonment, but as a pivot toward a leaner, faster alternative. Meanwhile, China has thrown down the gauntlet, announcing its own Mars Sample Return mission, potentially launching as early as 2028. If the U.S. falters, China could be the first to bring Martian samples to Earth, and the first to confirm whether life once thrived on the Red Planet. The geopolitical stakes are nothing short of monumental. For now, the Sapphire Canyon sample rests in a sealed tube on Mars's surface, a silent guardian of what could be humanity's greatest scientific discovery. It holds the potential to redefine our understanding of life's place in the cosmos, frozen in time, until we can retrieve it. But as that sample waits, a different kind of drama is unfolding closer to home. One that's forcing governments to face questions they'd rather avoid, questions that could reshape our future in ways we're only beginning to grasp. Chapter 3. The UFO Enigma. Congress unveils a cosmic riddle. On September 9, 2025, Congressman Eric Burleson from Missouri strode into a House Oversight Committee hearing and unveiled a bombshell that left the room and the world reeling. He played a video never before seen by the public, captured on October 30, 2024, by an MQ-9 Reaper drone off the coast of Yemen. The footage showed a luminous spherical object gliding through a dark sky, its eerie glow defying the night. Then a Hellfire missile streaked into the frame, striking the object dead on. What followed shattered every assumption about modern weaponry. The object didn't explode, didn't fragment, didn't even flinch. Instead, the missile seemed to ricochet harmlessly, continuing its path, while the orb sailed on unruffled. "That's a Hellfire missile smacking into that UFO and just bouncing off," Burleson declared, his voice thick with disbelief. And it kept going. He paused, letting the weight of the moment settle before posing the question now rippling through defense circles. Why are we being blocked from this information time and time again? The Yemen incident unfolded in a volatile combat zone where U.S. Navy ships and aircraft were guarding commercial shipping lanes against missiles and drones launched by Houthi militants. American forces were routinely neutralizing threats in the region, but this object, whatever it was, didn't behave like any known drone, missile, or aircraft. A Hellfire strike designed to obliterate targets should have left nothing but debris. Yet this orb shrugged it off, defying physics as we know it. When pressed to authenticate the video or provide details, the Department of Defense stonewalled. A DoD official told reporters, "We have nothing to provide on this." A spokesperson echoed, "I have nothing for you." The silence only deepened the mystery, fueling speculation and unease. The Yemen video wasn't the only revelation to electrify the hearing. Military veterans testifying under oath shared first-hand accounts of encounters with unidentified anomalous phenomena. UAPs, the government's current term for what were once called UFOs. Air Force veteran Dylan Bolin recounted a chilling incident from 2012 at Langley Air Force Base in Virginia. Stepping outside for a cigarette during an overnight shift, he spotted a triangular craft, hovering silently above him, motionless for several minutes. Then in a blink it rocketed to the altitude of a commercial jet and vanished at breakneck speed. Bolin reported the sighting through official channels and was interviewed by the Pentagon's All-Domain Anomaly Resolution Office, ARROW, in 2023. But instead of validation, he faced dismissal, workplace retaliation, manipulation of his security clearance, and blacklisting from federal intelligence jobs. His testimony painted a damning picture, a system that doesn't just neglect UAP reports but actively punishes those who dare speak out. The hearing wasn't merely about strange sightings, it was a battle cry for transparency. Representative Anna Paulina Luna, chairing the task force, opened the session with a searing statement. For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy, stigma, and in some cases outright dismissal. This is about national security, government accountability, and the American people's right to the truth. What sets this moment apart from decades of UFO lore is the credibility of the evidence. These aren't wild-eyed conspiracy theorists or blurry backyard videos. The witnesses are military personnel with impeccable records, security clearances, and operational experience. The Yemen footage comes from advanced military sensors captured during active operations in contested airspace. And the resistance to disclosure isn't from shadowy cabals, but from official Pentagon offices tasked with investigating these very incidents. AARO insists it has no verifiable evidence of extraterrestrial activity or technology, touting a rigorous scientific framework and a data-driven approach to understanding UAPs. Yet critics argue that the agency's explanations for compelling cases like the Yemen incident often strain credulity. Consider the 2015 Go Fast video, which showed a fast-moving object skimming above ocean waves off California. AARO attributed it to a weather balloon, claiming its apparent speed was an optical illusion caused by parallax in camera angles. But pilots who witness such objects firsthand through their eyes, not just sensors, insist these explanations don't hold water. Some analysts have suggested the Yemen orb might also be a balloon drifting in high-altitude winds and reflecting sunlight, with the missile missing its mark and the footage creating the illusion of a hit. Former senior intelligence official Luis Elizondo, who testified at the hearing, dismantled that theory. "We've never seen a Hellfire missile hit a target and bounce off," he said. "When a Hellfire strikes something solid, there's usually not much left. It's devastating." So where does this leave us? Either the U.S. military encountered technology so advanced it can withstand a direct missile strike without a scratch, or there's a mundane explanation the Pentagon refuses to share for reasons we can only speculate about. Neither possibility is reassuring. The National UFO Reporting Center logged over 2,000 UAP sightings in the first 6 months of 2025 alone, a sharp rise from previous years. The Pentagon received more than 750 new reports between May 2023 and June 2024. Whatever is happening in our skies is escalating, and more people are taking notice. As governments wrestle with these inexplicable aerial phenomena, a far more predictable but equally dramatic spectacle is unfolding above us, driven by the star that sustains all life on Earth. The cosmos is speaking, and we're only beginning to listen. Chapter 4. Solar Fury. The Sun's dazzling finale. In October 2024, scientists delivered news that should have seized global attention but was drowned out by the clamor of daily life. The Sun had reached solar maximum, the fiery crescendo of its 11-year activity cycle. To most, this sounds like esoteric astronomy, a footnote for researchers cloistered in observatories. But what's unfolding on our star is far from academic. It's a cosmic spectacle with consequences that could ripple through our lives. And the most breathtaking moments may still lie ahead. Solar maximum isn't the finale. It's the prelude to a phase of intense geomagnetic storms and auroras that could outshine the peak itself. Picture a firework saving its brightest burst for the final explosion before fading. The Sun is gearing up for its last gasp, and it promises to set the skies ablaze for the next 2 years. Solar physicist Dr. Pål Brekke of the Norwegian Space Agency put it succinctly. It's good news for aurora chasers. Peak auroral activity often comes a few years after solar maximum, so we're in for several years of high aurora activity. Let that sink in. We're not at the end of the show. We're approaching the grand finale, a celestial light show that could dazzle the planet. To understand why, we need to dive into what fuels these shimmering displays. During solar maximum, the Sun's surface becomes a chaotic tapestry of sunspots, dark, turbulent regions where its magnetic field lines twist and tangle under immense stress. When these lines snap and reconnect, they unleash colossal bursts of energy in the form of solar flares and coronal mass ejection CMEs. A single CME can catapult billions of tons of plasma into space at speeds exceeding 1,000,000 miles per hour. When this charged torrent collides with Earth's magnetic field, It sparks geomagnetic storms, funneling particles toward the poles, where they slam into atmospheric atoms, igniting the vibrant curtains of light. We call auroras green, pink, and purple veils dancing across the night sky. But the story takes a fascinating turn after solar maximum. As the sun's explosive flares and CMEs begin to wane, you'd expect auroras to fade. Instead, the opposite happens. During the declining phase of the solar cycle, vast coronal holes emerge, dark, gaping regions in the sun's atmosphere where magnetic field lines stretch open into space. These holes unleash relentless streams of high-speed solar wind, sometimes persisting for weeks or months. Unlike the sudden violent impacts of CMEs, these solar winds batter Earth's magnetic field, with sustained force triggering geomagnetic storms just as spectacular. Solar physicist Dr. Sarah Gibson explained, "During the declining phase, we often see more geomagnetic storms. The sun's eruption rate slows after solar maximum, but coronal holes and lingering flares combine to produce frequent, sometimes more intense auroral displays. We're already witnessing this cosmic drama unfold. In early October 2025, Earth endured 5 consecutive days of geomagnetic activity driven by a high-speed solar wind stream from a coronal hole. Wind speeds peaked at 768 km/s, before easing to 608 km/s, still potent enough to spark isolated G1 minor geomagnetic storms. Auroras erupted across northern latitudes visible as far south as New York on some nights. Photographers in Iceland, Norway, Canada, and the northern U.S. captured breathtaking images of shimmering lights rippling across the heavens. And this was merely a prelude. An M1 5-class solar flare in early October launched a small CME expected to graze Earth around October 8th, potentially igniting another round of auroral brilliance. Scientists predict that solar cycle 25, our current cycle, will sustain high geomagnetic activity well into 2027 or beyond, fueled by this potent mix of lingering eruptions and persistent coronal holes. But another factor amplifies the show: Earth's orientation during the equinox season, which extends into early October. During equinoxes, the angle of Earth's magnetic field aligns with the incoming solar wind, creating a pathway for more charged particles to penetrate our defenses. It's like swinging open a door that's usually bolted shut, allowing stronger, more vibrant auroras to light up the skies. The implications of this solar fury extend far beyond beauty. Geomagnetic storms can wreak havoc on modern technology, disrupting radio communications, scrambling GPS signals, causing satellite orbits to decay, and in extreme cases threatening power grids. The infamous March 1989 geomagnetic storm triggered by a massive CME plunged Quebec into darkness for 9 hours, overheating transformers and tripping circuit breakers. That storm reached G5 extreme levels on the geomagnetic storm scale. By contrast, the storms of October 2025 have ranged from G1 to G3 minor to moderate, but they're still potent enough to challenge satellite operators and pilots flying polar routes where radiation risks escalate. Scientists track geomagnetic activity using the KP index, a scale from 0 to 9 with 5 or higher signaling storm conditions. In the first week of October 2025, the KP index oscillated between 3 and 5 with brief spikes into storm territory. Forecasters anticipate this pattern will persist with frequent unsettled to active conditions punctuated by occasional stronger storms over the coming months. For most of us, the impact is pure wonder. Auroras are among Earth's most awe-inspiring natural phenomena, and the next 2 years could offer some of the best viewing opportunities in decades. Those living above 50 degrees latitude north or south will have regular chances to witness the lights, but even mid-latitude observers down to 40 deg may catch glimpses during stronger storms. The sun's last gasp is shaping up to be a light show for the ages, a cosmic symphony painted across our skies. Yet as our star captivates us with its fiery farewell, other visitors from the depths of space are drawing near, celestial wanderers bringing their own mysteries and spectacles to our doorstep. Chapter 5. Celestial Symphony. 3 green comets blaze across October skies. In October 2025, the heavens are staging an extraordinary spectacle, a cosmic performance that defies imagination. Look up on the perfect night from an ideal vantage point far from the glow of city lights, and you might behold a rare celestial trifecta. Not one, not two, but 3 comets painting the sky with their ethereal green glow. Each of these celestial wanderers was discovered in the fleeting months of this year, and together they weave a narrative of cosmic wonder. One of them shining brighter than anticipated may even grace the naked eye, a fleeting gift in an era when most comets remain elusive faint whispers in the vastness of space. At the heart of this celestial drama is Comet C 2025, A6, fondly named Comet Lemon, after Arizona's Mount Lemmon Observatory, where it was first glimpsed on January 3, 2025. When discovered, it glimmered faintly at magnitude 21.5, so dim that astronomers initially mistook it for an asteroid drifting through the void. It wasn't until meticulous follow-up observations revealed a condensed coma, a glowing halo of gas and dust, and a short wispy tail that its true identity as a comet was confirmed. For much of the year, Lemon remained a quiet curiosity tracked by dedicated astronomers with powerful telescopes, while the public remained largely unaware of its existence. Early predictions charted a modest path for Lemon, forecasting a peak brightness of magnitude 9 by early November, bright enough for backyard telescopes but far from the realm of naked eye visibility. Then, in a twist that thrilled the astronomical community, Lemon rewrote its own story. Emerging from solar conjunction in mid-August when it was obscured by the sun's blinding glare, observers were stunned to find it significantly brighter than expected. By August 19th, its magnitude had surged to 11 and a short, spiky tail became visible, hinting at the comet's growing vigor. The brightening didn't stop there. By late September, Comet Lemon had climbed to magnitude 8 to 9, easily spotted through binoculars and small telescopes. Astrophotographers began sharing breathtaking images capturing not only the comet's radiant nucleus and surrounding coma, but also a dynamic ion tail stretching away from the sun, adorned with intricate twirls and knots as it danced with the solar wind's invisible currents. By September 30th, Lemon had reached magnitude 6.6, its ion tail spanning an impressive 3 degrees across the sky, with a fainter dust tail beginning to emerge. Astronomers updating projections almost daily as new observations pour in. Now estimate that Lemon could reach magnitude 4, or even a dazzling magnitude 3, during its closest approach to Earth on October 21st, at a distance of 56 million miles. This places it tantalizingly close to naked eye visibility, where it may appear as a faint fuzzy star in pristine dark sky locations far from urban light pollution. Unlike many comets that peak when too close to the sun for safe observation, Lemon is perfectly positioned, shining in the evening sky about 42 degrees from the sun, visible in the west roughly an hour after sunset. Its brilliance is expected to intensify as it hurtles toward perihelion, its closest approach to the sun, on November 8th. For observers in the northern hemisphere, the best viewing window spans Halloween into early November, when Lemon glides through the constellation Fornax, offering a once-in-a-lifetime spectacle. With an orbit so elongated that it may not return for 350 years if it returns at all, this comet is a fleeting marvel, a cosmic visitor gracing our skies for a single unforgettable moment. Yet Lemon is not alone in this celestial parade. Enter Comet C 2025 R2 Swan, a newcomer discovered mere weeks ago, just one day before its closest approach to the sun. Hidden by the sun's glare until then, it evaded ground-based telescopes, but was spotted by keen-eyed amateur astronomers Vladimir Bazugli and Michael Matiazzo in images from NASA's Solar and Heliospheric Observatory SOHO, a space-based telescope designed to study the sun, hence the comet's namesake Swan. Now, moving away from the sun, Swan won't grow brighter but will become easier to observe as it distances itself from the solar glare. On October 20th, it makes its closest approach to Earth at 24 million miles, its tail already captured in stunning photographs stretching past the bright star Spica. This weekend, it will pass within a degree of Mars, creating a breathtaking opportunity for astrophotographers to frame the comet and the red planet in a single awe-inspiring shot, a celestial dance frozen in time. Completing this cosmic trio is Comet C 2025 K18 Atlas, named after the asteroid terrestrial impact last alert system Atlas, a survey designed to detect near-Earth asteroids but astute enough to catch comets in its gaze. Though fainter than its companions, Atlas is steadily brightening as it approaches the sun, rewarding patient pre-dawn. Observers equipped with binoculars or small telescopes, its subtle glow adds a quiet elegance to this vibrant trio, a reminder of the diverse beauty of the cosmos. What gives these comets their striking green hue? The answer lies in diatomic carbon molecules, pairs of carbon atoms bonded together that absorb sunlight and emit light at a wavelength that appears green to human eyes. As comets draw closer to the sun, solar radiation heats their icy cores, breaking down complex organic molecules and releasing diatomic carbon into the surrounding coma. The closer they get, the more carbon is liberated, intensifying their emerald glow. Remarkably, a fourth green comet, the interstellar visitor, TK 2025 Atlas, has recently joined the scene, shifting from a crimson hue to a vibrant emerald as it interacts with solar radiation in ways that continue to puzzle astronomers. Its enigmatic transformation is a story for another chapter, but it underscores the unpredictable magic of these celestial travelers. Comet Lemon in particular has exceeded all expectations, sparking excitement among astronomers worldwide. Nick James, director of the Comet section of the British Astronomical Association, told spaceweather.com, "This comet is unfolding beautifully, a truly impressive object in the morning sky. It's well worth rising early to witness." Comets are the wild cards of the cosmos, far less predictable than the steady orbits of planets or the constant glow of stars. They can flare in sudden outbursts, fragment without warning, or fade into obscurity just when they're expected to dazzle. Predicting their behavior is akin to forecasting weather 6 months in advance, an exercise in physics tempered by nature's penchant for surprises. Lemon's unexpected brilliance, Swan's last-minute discovery, and Atlas's quiet ascent embody this unpredictability, making them all the more captivating. October 2025 is a month of cosmic convergence. 3 green comets streak through our skies, one teetering on the edge of naked eye visibility. The sun pulses with activity, casting auroras that dance at mid-latitudes. Asteroids slip past Earth's defenses, reminding us of our place in a dynamic universe. On Mars, a rock etched with patterns that might hint at ancient life stirs speculation. Amid this natural spectacle, human ambition reaches for the stars as one company prepares to launch the most powerful rocket ever built, a machine poised to either revolutionize space exploration or join the long history of bold dreams that fell short. The cosmos is alive with wonder, and October 2025 is its grand stage, inviting us to look up and marvel at the infinite possibilities above. Chapter 6, Starship's Triumphant Finale. A make-or-break triumph on October 13, 2025. A date etched into the annals of space exploration, where the roar of humanity's most ambitious rocket echoed across the Texas Gulf Coast. If SpaceX's audacious plans held firm, and with this company's certainty is as elusive as a comet's tail, the world tuned in for the 11th test flight of Starship, the colossal behemoth, standing 403 feet tall, boasting unmatched power and dreams of Mars. But this launch transcended routine testing. It marked the swan song for Starship version 2, the iteration that had weathered storms of fire and fury. What followed was not just a flight, but a redemption arc, propelling the program toward version 3's grander horizons, bigger, bolder, and engineered for unbreakable reliability. The burning question lingered. Could version 2 exit the stage with glory, or would it cap a turbulent year with yet another cataclysmic blaze? Let's confront the specter haunting the program. 2025 had battered Starship with unrelenting setbacks, testing the resolve of engineers, executives, and enthusiasts alike. The year ignited with back-to-back infernos that rattled faith in the entire endeavor. Flight 7 in January witnessed the upper stage, affectionately dubbed Ship, succumb to a catastrophic disintegration mere moments into its ascent burn. 4 of its 6 Raptor engines faltered prematurely, spiraling the vehicle into chaos with lost attitude control and severed telemetry. The dramatic breakup lit up the horizon, visible from Florida's shores to Jamaica, and the Turks and Caicos Islands, a fiery spectacle that underscored the raw peril of pushing boundaries. Flight 8 in March teased victory before snatching it away. The Super Heavy booster executed a jaw-dropping feat, snared mid-air, by the launch tower's mechanical arms, a ballet of precision that marked a historic milestone in reusable rocketry. Yet Ship 34 faltered. 4 engines quit during its burn, unleashing a loss of control that culminated in structural failure. 9. 2 minutes post-liftoff. Debris rained into the Atlantic, a stark reminder of the stakes. Then Flight 9 in May introduced another breakthrough, the debut of a reused Super Heavy booster, a nod to rapid reusability. But the upper stage faltered once more, unable to fulfill its objectives amid leaks and instability. 3 consecutive heartbreaks, 3 ships sacrificed, 3 exhaustive investigations, 3 waves of frantic redesigns and vows that the next would rewrite the narrative. Skeptics whispered of fundamental flaws. Optimists clung to the iterative philosophy, fail fast, learn faster. Relief dawned with Flight 10 in August, shattering the slump in spectacular fashion. Every system hummed in harmony. The booster executed a flawless splashdown in the Gulf of Mexico. Ship soared through its suborbital ballet, piercing re-entry with an intact heat shield before a pinpoint water landing in the Indian Ocean. It even unfurled a payload bay to deploy Starlink simulators, dummy satellites, mirroring future commercial cargo. A pivotal proof of concept that ignited cheers across Starbase. For the first time in grueling months, SpaceX's tribe could breathe the air thick with vindication and momentum. Now Flight 11 ignited at 6:23 p.m. Central Time from Starbase in South Texas, a coastal outpost pulsing with innovation. The mission blueprint echoed Flight 10's proven path, but amplified the ambition, layering in risks that could either forge the future or fuel fresh doubts. The star booster B-15 was no novice. It had thundered skyward on Flight 8 in March, earning its flight-proven stripes via a triumphant tower catch. This reprise armed it with 24 battle-tested Raptor engines, relics of prior launches now reborn for another gauntlet. Yet the real intrigue lay in the landing sequence, a daring preview of version 3's playbook. Foregoing a tower catch, B-15 embarked on a choreographed descent over the Gulf, igniting 13 engines for the initial landing burn, then pivoting to a novel 5-engine divert phase for enhanced redundancy against the spontaneous shutdowns that had doomed prior attempts. Culminating with its 3 central engines, the booster would hover triumphantly before a controlled splashdown. SpaceX branded it a stress test, a crucible to quantify vehicle dynamics amid engine transition, success validating version 3's resilience, failure at least confined to watery obscurity far from the pad. Ship 38, the upper stage counterpart, brimmed with its own high-wire act. It would dispense 8 Starlink simulators, meticulous replicas in size, and massive next-gen satellites destined for commercial constellations. Though doomed to re-entry incineration on this suborbital jaunt, their release honed deployment mechanisms and protocols for orbital reality. Ship 38 pressed further, reigniting a single Raptor in the vacuum of space, a ballet of cryogenic precision essential for lunar slingshots, Martian insertions, or any Odyssey demanding mid-flight agility. Re-entry loomed as the gauntlet engineers had excised tiles from strategic hotspots, exposing vulnerabilities sans ablative backups. Plasma infernos could sear through gaps, igniting structural Armageddon, but knowledge demanded sacrifice. Only by courting catastrophe could SpaceX map the heat shield's breaking points and fortify for survival. Assuming endurance, Ship 38 would execute a dynamic banking maneuver, in descent refining subsonic algorithms for future tower returns. A final landing burn would crown it with a splashdown in the Indian Ocean, ideally intact, brimming with telemetry treasures. Liftoff thundered at 7:23 p.m. Eastern, a symphony of flame and fury propelling the stack heavenward. Ascent unfolded flawlessly, stage separation a seamless handover. B-15 aced its boostback, enduring a solitary engine hiccup during the divert, but pressing on with the 13-5-3 sequence. Hover achieved, engines quiesced, and it plunged into the Gulf, culminating in a deliberate self-destruct post-splashdown, a controlled finale yielding oceans of data. Ship 38, meanwhile, unfurled its payload with grace, 8 simulators tumbling free like cosmic confetti. The in-space relights sparked to life, a fleeting blue flame affirming orbital prowess. Re-entry's hellfire tested the scarred shield, Plasma clawed at exposed flanks, but the ship held, banking dynamically through the inferno before igniting for a feather-soft splashdown mere meters from target, captured in crystalline footage by recovery buoys bobbing in the Indian waves. This triumph wasn't mere luck. It was the alchemy of 10 prior flight scars. Explosions transmuted into evolution. Version 3 looms larger ships with amplified propellant reservoirs and payload bays. Boosters swollen with extra raptors and thrust. Infused with its decades' hard-won wisdom, it promises operational maturity. Yet Flight 11's shadow loomed long. A mid-re-entry rupture could have armed detractors with proof of inherent defects. A botched booster burned doubts on scalability. Spectacle gone awry might strain NASA's tether as Artemis III eyes 2027 in lunar boots hinging on Starship's lunar variant. The stakes, stratospheric. Starship isn't hardware. It's SpaceX's manifesto, a portal to orbital thrift Mars. Metropolis's satellite swarms in orbit, refueling, and human epics beyond sci-fi reverie. But first, survival over spectacle. As the launch window cracked open on that fateful October eve, millions riveted to screens, hearts sinking in the hush before ignition. A singular plea hung unspoken. Please don't explode. Version 2 bowed out unbowed. Igniting the Version 3 dawn. While SpaceX hones this titan, another power surges forth, a distant probe billions of miles outbound, probing an ancient scar that may unravel the moon's cataclysmic cradle and our own origins in the cosmic forge. Chapter 7. Echoes of the Moon. Tianwen-2's audacious quest into cosmic shadows. On the hushed pre-dawn of May 28, 2025 at 1:31 a.m. Local time, a Long March 3B rocket pierced the velvet sky above Xichang Satellite Launch Center in Sichuan Province, China. To most of the world, it was a fleeting streak of fire lost amid the daily churn of global headlines. Yet aboard that soaring pillar of flame rode a probe poised to unravel one of the solar system's most tantalizing enigmas. Could a fragment of the moon be masquerading as an asteroid locked in an eternal waltz around Earth? Tianwen-2. China's bold second foray into planetary exploration isn't just chasing rocks, it's hunting for the scars of ancient cataclysms that forged our cosmic neighborhood. The Tianwen saga, evoking the ancient poetic queries to the heavens, traces a lineage of lunar triumphs and Martian marvels. Tianwen-1 launched in 2020 delivered an orbiter and rover to the Red Planet, where Zhurong still roams dusty plains beaming data back home. Tianwen-3 eyes a 2028 Mars sample return, potentially eclipsing NASA's beleaguered Perseverance haul. Tianwen-4, slated for 2030, will probe Jupiter's swirling storms and Uranus's icy veil in a single audacious leap. But Tianwen-2 turns its gaze inward to a quarry deceptively near 46929 Kamo-Oalewa, or asteroid 2016 H03, a enigmatic quasi-satellite that shadows Earth like a ghostly companion. Kamo-Oalewa defies easy classification. This near-Earth object orbits the Sun in near-perfect synchrony with our planet, completing a solar lap every 365 days, while tracing a subtle looping path from our vantage, never drifting farther than 100 million kilometers, yet never succumbing to our gravity's full embrace. Roughly 40 to 100 meters across the span of a Ferris wheel, it spins wildly once every 28 minutes, a cosmic top, defying the sluggish tumble of most asteroids. Discovered in 2016 by Hawaii's Pan-STARRS telescope, its Hawaiian name whispers of an oscillating fragment from the heavens, a nod to a creation chant evoking a child adrift yet tethered to its origin. What elevates Kamo-Oalewa from curiosity to conundrum is its spectral fingerprint, the unique way it scatters sunlight. In 2021, astronomer Benjamin Sharkey's team, peering through Arizona's large binocular telescope, unveiled a revelation. Its reflectance mirrored the space-weathered silicates of Apollo lunar samples, not the basaltic hues of typical asteroids. Further sleuthing in 2023 and 2024 bolstered the case, with orbital models tracing its path to the moon's far side Giordano Bruno crater, a 22-kilometer scar blasted open 1 to 10 million years ago by a kilometer-wide impactor. If true, Kamo-Oalewa is no interloper, but ejecta, a colossal boulder hurled skyward by that primordial hammer blow, propelled just beyond lunar escape velocity to claim its quasi-orbit. Such a relic could chronicle the moon's bombardment epoch, revealing impact energies that pocked its cratered visage and perhaps even seeding Earth with life's precursors. Untainted by terrestrial winds or waters, its grains promise pristine lunar highland crust, a time capsule from the solar system's violent youth. Yet doubt lingers like cosmic dust. Kamo'alewa might hail from the main asteroid belt, nudged into this resonant dance by unseen gravitational whispers pathways our models scarcely fathom. Silicate echoes could be coincidence or the remnant of a shattered precursor caught in Earth-Moon tides. Resolution demands more than telescopes. It craves touch. Enter Tianwen-2, engineered for intimacy, a 2,000-kilogram marvel, unfurling solar sails to sip sunlight for electric propulsion across the void. Launch unfolded flawlessly, the Long March 3 marking its interplanetary debut, vaulting the probe to escape velocity on an eastward arc. By June 6, over 3 million kilometers outbound, the China National Space Administration (CNSA) shared a crisp snapshot. One solar array gleaming against the star-pricked abyss snapped by an onboard camera. A mundane miracle affirming vitality amid the infinite. As of October 21, 2025, Tianwen-2 hums steadily toward its first deep space burn. On October 30th, some 46 million kilometers distant, refining its trajectory with solar electric finesse. Arrival at Kamo'alewa looms in mid-2026, ushering a year of orbital reconnaissance, multispectral cameras charting its irregular silhouette, spectrometers probing composition radars, gauging mass, all while grappling with the asteroid's blistering spin and feeble gravity. Sampling the diminutive dancer will test human ingenuity's edge. At a mere 40 to 100 meters, Kamo'alewa dwarfs no prior target. OSIRIS-REx's Bennu sprawled 500 meters wide. Hayabusa 2's Ryugu, a 900-meter boulder. China deploys a trio of tactics for redundancy. First, a hovering ballet, the lander sinks rotation hovering meters above to vacuum surface regolith, or expose subsurface volatiles with micro-explosives. Second, the proven touch-and-go, a fleeting kiss to snag grains before ascent, echoing NASA's and JAXA's triumphs. Third, the bold anchor and drill legs tipped with augur's burrow and tethering for extended harvest, a global first demanding flawless autonomy amid 20-minute light speed lags. Target yield at least 100 grams, 3 ounces of regolith, precious as stardust when autonomy reigns, and every gram charts failure's brink. Secured, the bounty transfers to a re-entry capsule, and Tianwen-2 pivots homeward. By late 2027, 2.5 years post-launch, the pod plummets earthward at 12.1 kilocalories, outpacing lunar returnees like Chang'e 5's 10.7 kilometers, forging a plasma sheath hotter and fiercer than any Chinese shield has braved. Parachutes will cradle it to the Gobi's embrace, samples destined for labs to whisper of lunar origins or belt-borne wanderings. But Tianwen-2's odyssey endures. Post-drop, an Earth gravity assist hurls the mothership sunward toward main belt comet 311P Pan-STARRS, a hybrid oddity blending asteroid grit with cometary ice. 7 years hence, mid-2030s arrival, it will orbit this elusive sprite for months, spectrometers and imagers dissecting its dual nature, probing water and organics genesis. A decade-long epic one-vessel duel, Destiny's sample return from a quasi-satellite rendezvous with the comet Phantom. This symphony of ambition underscores China's ascent. While NASA grapples with fiscal scissors, talent exodus, and partisan tempests, its Mars sample return ballooning costs and timelines. Tianwen-2, launched on schedule, a testament to Beijing's blueprint, steady funding, modular prowess mission stacking like lunar layers. If Kamo'alewa's grains confirm lunar lineage, China claims a scientific coup, decoding bombardment chronicles while flaunting deep space mastery. Should Tianwen-3 follow with Martian hauls as NASA's lags, the optics sharpen a new space race, not of Cold War sprints but marathon engineering, where patience yields payloads. The contest evolves finish lines. Fluid paths divergent, America chases crude horizons amid bureaucratic tempests. China methodically maps the void, launch by launch, datum by datum. Today, October 21, 2025, Tianwen-2 streaks farther millions of kilometers, and counting, propelled by photons and plasma. toward a speck few know by name. When it grasps those grains when they plummet home in 2027, spotlights will converge. For in that descent China joins an elite trio, United States, Japan, and now the Middle Kingdom bearing trophies from beyond the moon's pale glow. Yet as Beijing's probes weave solar tapestries with precision, NASA's storied halls echo with peril. The agency that etched bootprints in regolith now confronts an abyss slashed budgets eroding missions' mid-flight expertise, hemorrhaging to private stars visions of Mars deferred by earthly discord. Decades of triumphs teeter launched dreams imperiled a crisis that could unravel the thread binding humanity's stellar ascent. Chapter 8: NASA's Existential Reckoning. Shutdown exodus and the fierce struggle to preserve cosmic discovery. At precisely 12:01 a.m. on October 1, 2025, the United States federal government shuddered to a halt, casting NASA into a maelstrom of uncertainty that reverberated from Houston's Mission Control to Pasadena's Jet Propulsion Laboratory. Within hours, 15,000 of NASA's 18,000-strong workforce engineers, scientists and visionaries who propel humanity's reach into the cosmos received furlough notices ordered to abandon their posts. Laboratories fell silent, computer screens went dark, and the pulse of ongoing research flatlined across the agency's sprawling network of centers. Offices locked, experiments stalled, and the relentless march of discovery ground to an unprecedented pause. Yet for a resolute 3,000 is deemed essential, the mission endured without pay. These unsung stewards, from mission controllers to systems engineers, toiled under the specter of empty bank accounts logging hours, with only the faint promise of retroactive compensation once Congress resolves its budgetary stalemate. They're charged to keep spacecraft soaring and astronauts alive, a duty too vital to falter. Mission control for the International Space Station ISS remains a beacon of continuity, its teams issuing 1,000 commands daily to sustain life support, stabilize orbits, and avert crises. A single misstep could endanger the crew orbiting 400 kilometers above, so these guardians work unpaid, their monitors aglow with telemetry, while political gridlock festers below. Similarly, the Artemis program, NASA's audacious bid to return humans to the lunar surface, stands as a national security linchpin, its urgency crystallized by Acting Administrator Shaw Duffy's stark warning on China is not going to the moon with good intentions. The message is unequivocal: seeding the lunar frontier is unthinkable. Artemis II, a crewed lunar flyby slated for February 2026, and Artemis III, the 2027 moon landing, are shielded from furloughs. Thousands of NASA employees alongside contractors at SpaceX and Blue Origin crafting lunar landers and critical hardware press forward, logging unpaid hours to preserve schedules already strained by delays. Any further slippage risks handing China with its methodical lunar ambitions a geopolitical triumph. This shutdown, however, is merely the latest tremor in a seismic crisis that has been fracturing NASA throughout 2025. The agency's woes trace back to early in the year when the Office of Management and Budget, in concert with Duffy, issued a devastating directive slashed the workforce by over 4,000 employees, more than 20% of its ranks, through deferred resignation offers spanning September 2025 to January 9, 2026. These aren't temporary furloughs, but permanent departures, bleeding NASA of irreplaceable talent. Engineers who architected Artemis's intricate systems, scientists steering probes to distant worlds, and specialists in propulsion power and life support are walking away. A whistleblower at Johnson Space Center, speaking anonymously to SpacePolicyOnline.com, mourned the loss of a preeminent power systems expert, whose expertise was pivotal for the nuclear reactor destined to power lunar outposts. "We're losing decades of knowledge," the insider lamented, "at a time when we need it most." The root of this exodus lies in a toxic brew of budget uncertainty and political pressure. President Trump's proposed fiscal year 2026 budget delivers a gut punch, slashing NASA's funding to its lowest inflation-adjusted level since 1961, when Alan Shepard's 15-minute suborbital hop marked America's first spaceflight. Science programs face a staggering 47% cut, threatening to terminate 41 missions, many already operational, their instruments piercing the cosmos. The toll is staggering: spacecraft silenced mid-flight, discoveries forsaken, and billions in taxpayer investment reduced to cosmic debris. The Nancy Grace Roman Space Telescope, nearly complete and poised to catalog billions of galaxies and thousands of exoplanets, teeters on cancellation. OSIRIS Apex, en route to study asteroid Apophis during its 2029 Earth flyby, faces being powered down mid-journey. The Mars sample return with Perseverance's meticulously curated Martian rocks awaiting retrieval risks. Abandonment potentially allowing China's Tianwen-3 to claim the first Martian samples. Even legendary missions are imperiled, the Chandra X-ray Observatory rewriting astrophysics since 1999, and the Hubble Space Telescope humanity's cosmic lens for 35 years. Face/support or outright termination. The cuts ripple beyond deep space. Earth science missions monitoring climate shifts, tracking deforestation, measuring sea level rise, and fueling weather forecasts and disaster response stand gutted. Planetary defense tasked with detecting Earth-threatening asteroids sees its vigilance dimmed, a bitter irony after the undetected flyby of asteroid 2025 TF, which grazed Earth at a mere 1.2 million kilometers on October 4th. Whistleblowers within NASA decry the administration's actions as illegal, accusing it of imposing unapproved budgets in defiance of Congress and NASA's own regulations. They're breaking constitutional principles, one insider told Space News, noting that NASA's legal office should know better. Yet the violations persist, veiled from public scrutiny, as political priorities override scientific imperatives. The human cost is profound, extending far beyond NASA's walls. Universities nationwide tethered to NASA grants face frozen funds, collapsing research programs. Graduate students lose stipends mid-degree, their academic futures upended. Professors scramble for emergency aid to sustain labs. Astrophysicist Stephen McCandless at Johns Hopkins, leading NASA's sounding rocket program, secured temporary university funding to weather a launch, but smaller institutions lack such cushions. Entire fields risk hollowing out as researchers unable to endure the uncertainty abandon space science for private industry or unrelated careers. Decades of institutional knowledge hard-won through Apollo Voyager and Hubble evaporate, a loss no budget can restore. International partners bound to NASA through agreements on Mars sample return Artemis and joint observatories watch with mounting unease. The European Space Agency ESA, Japan's JAXA, and Canada's CSA have invested billions in decades, and collaborations now jeopardized by NASA's unilateral retreats. Cancellations or delays trigger cost overruns and erode trust, tarnishing America's reputation as a reliable steward of global space exploration. The ESA's contributions to Mars sample return, including a fetch rover and Earth return orbiter, hang in limbo as NASA's funding falters, straining partnerships forged over decades. The deeper wound is to scientific momentum and public trust. Space exploration is a marathon, not a sprint. Missions demand years, sometimes decades, of planning, construction, and execution, governed by the inflexible rhythms of orbital mechanics. A Jupiter probe can't wait for a budget resolution. A planetary alignment won't pause for political squabbles. Halting a spacecraft mid-flight like OSIRIS Apex or Chandra squanders irreplaceable data. Restarting canceled programs requires rebuilding teams, redesigning systems, and realigning launch windows, often at triple the cost. Each lost expert erodes NASA's capacity to innovate. Each axed mission is a discovery forever out of reach. The compounding damage threatens to unravel a legacy that spans moon landings, Martian rovers, and telescopes that unveiled the universe's infancy. Yet amid the gloom, resistance kindles. Protests erupt outside NASA's Washington headquarters, where employees, scientists, and supporters brandish signs demanding full funding and an end to the cuts. Bipartisan lawmakers, particularly from states hosting NASA hubs like Texas, Florida, and California, push back with appropriations bills exceeding the president's austere request. As of October 21, 2025, no budget is finalized, leaving NASA's fate in limbo. Advocacy groups like the Planetary Society and the National Space Society rally public support, urging citizens to press Congress to protect the agency that delivered Apollo's triumphs. Curiosity's Martian treks, Hubble's cosmic portraits, and Webb's infrared revelations. The space community's mantra echoes: exploration unites us, transcending borders and budgets. NASA stands at a crossroads. One path leads to revitalized exploration, groundbreaking discoveries, and reaffirmed American leadership in space. The other descends into managed decline, canceled missions, lost expertise, and a diminished role as nations like China surge forward with missions like Tianwen-2, now streaking toward Kama'oalewa with unerring precision. The choice rests not with scientists or engineers, but with politicians and bureaucrats, many insulated from the fallout of their decisions. Meanwhile, those who've dedicated their lives to unraveling the cosmos watch helplessly as their work is dismantled piece by irreplaceable piece. October 2025 unfolds against a restless universe. Asteroids slip past undetected Martian rocks hinting at ancient life. Languish uncollected, unexplained aerial phenomena flicker in military footage, and 3 green comets blaze through a hyperactive solar maximum. SpaceX's Starship, a private colossus, roars toward its version 3 future, while NASA, the agency that once etched humanity's footprints on the moon, fights to keep its lights on. The cosmos spins on, indifferent to our earthly squabbles, its auroras shimmer, its mysteries beckon, its vastness humbles. Every discovery we pursue, every enigma we decode reaffirms our place in a tapestry far grander than ourselves. But as NASA teeters on the brink, that truth risks fading into shadow at the very moment when its light is needed most.